Okay, today we're going to be doing solving absolute value equations. Go ahead and press pause in the video and go ahead and answer those two questions. And I'll go ahead and start in a little bit. But press pause on the video right now and attempt the first two problems. All right, this is what you should have ended up with. On the left-hand side, you should have done a bunch of math. Remember, you distribute first, and the answer you should have gotten was -1. If you did not get -1, press pause on the video and go through the solution and see where you might have messed up. On the second one, remember that the absolute value of a number means how far it is from 0. So because 6 is 6 spaces away from 0, here's 0, and here's the number 6. Because it takes 6 spaces, how many was that? Well, it's 6, right? Since it's 6 spaces away from 0, the absolute value of 6 is 6. And -6, you do the exact same thing. Since -6 is 1, 2, 3, 4, 5, 6 spaces away from 0, then the absolute value of -6 is also 6. Okay? So what's the difference between absolute value of 6 and absolute value of -6? There is no difference. In their answers. Okay, they didn't ask you to do this, but I want to show you something really quickly. Let's just pretend, and I'm going to do this in a different color. You don't need to put this in your notebook. I actually did this in class on the whiteboard, so don't write this down. But what I asked you guys in class earlier was absolute value of x is equal to 4. So I'm thinking of a number, and when I take the absolute value of that number, the answer is 4. What number am I thinking about? Well, what we came up with was that if I said that x is 4, that works. Because if I take the 4 and I plug it in, absolute value of 4 is 4. But then some other students also said, wait a minute, maybe you were thinking of the number -4. Because when you take -4 and take the absolute value of -4, you also get 4. So that works. What I'm trying to say is when you ended up with this mystery number, the absolute value, and then the answer was positive, we actually ended up with two different answers. Okay. The next thing I did was I asked you guys, all right, let's play that again, but this time I'm thinking of a number, and the answer I got was -2. So students, just like last time, they went ahead and they said, oh, okay, you must be thinking of 2. Except when we tried that, right, if I take the absolute value of 2, it's 2. And I'm trying to get -2 to be my answer. So that one actually did not work. They said, oh, okay, so then the answer must be -2. Except when I take the -2 and I plug it in, absolute value -2 is +2, but I'm trying to get a -2. So actually that one didn't work either. So what number, when I take the absolute value of it, is going to give me that -2? Well, there is no number that'll work. So in this case, we actually ended up with no solution. And that's really important that you understand this, guys. Look, when you had a positive number out here, there was two different numbers that worked for that positive number. So we got two answers. But when my absolute value was a negative answer, like we cannot force this part to become negative. So we ended up with no solution. Okay, just kind of keep that in the back of your head because we are going to be using that in a little bit. All right, now that we have that, let's go ahead and talk about the steps to solve absolute value equations. Step number 1 is going to be to isolate the absolute value. When I say isolate, I mean I need to get that absolute value completely by itself. If you are isolated, that means you're by itself, that there's nothing around you, okay? Once you isolate the absolute value expression, you're going to set up your two cases. The first equation is going to be exactly the same. And for the second case, we're going to change all the signs on the non-absolute value side. So the side that does not have the absolute value, we're going to change all the signs on that side. We're going to make it completely opposite. We're going to then solve both equations separately. And then we're going to check for extraneous solutions. Extraneous solutions are solutions that are fake. That is to say, they look like they're going to work, but then when you plug it back in, you realize, oh no, that actually did not work. It's almost like a fake ID. right? It looks like it's real, but then once you really take a closer look at it, you go, oh no, this is actually not going to work, okay? All right, so when solving absolute value equations, there are three different types of solutions. Let me show you what those solutions are going to look like. So I'm going to use the same example, and I'm going to just tweak something very short to it. So the first one's going to look like this. Absolute value of 2x minus 3 is equal to 4. The second one is going to look like this. Absolute value of 2x minus 3 is equal to x plus 4. And then the last one's going to look like this. Absolute value of 2x minus 3 is equal to negative 4. So let's take a look at those three, and let's see what makes them different. Well, obviously the left-hand side is the same, right? You have the absolute value of something. And what happened? Well, let's see. On the left-hand side, you ended up with a positive number as your answer. When you end up with a positive number as your answer, you're going to end up with two solutions. So the answer, nope, let me not write answer. Let me write the non-absolute value side. That is to say, the side that does not have the absolute value was positive. And when you have that case, then you're going to end up with two solutions. There are going to be two answers, okay? I'm going to skip the middle one for now. We're going to go to the last one. We're going to say, okay, in this case, I have the absolute value of something and the answer is negative. Well, like you saw earlier up here, if you're going to take the absolute value of something and trying to get a negative number, there's nothing inside that absolute value that can make your final answer a negative. So because this absolute value has a negative as an answer, then I'm going to say when you have the non-absolute value side, is negative, then in that case, we are going to end up with no solution. In fact, let me highlight those. When this is negative, you're going to end up with no solution. When this is positive, you're going to end up with two solutions. So let's talk about that one in the middle. Hey, that x can be any number. So I don't know if it's positive. I don't know if it's negative. It might be both positive. I mean, I just don't know, right? So this x, what's different about this one, it has an x. And with that x, I don't know if that answer is going to be positive or negative. So in this case, when the non-absolute value side has a variable, then here we need to check for extraneous solutions. That is to say, you might get some answers. You're gonna probably end up finding two answers, but one of them might be fake. Both of them might be fake. Both of them might be real. We have no idea, so we need to check our answers. Okay, and you'll see how that works in tomorrow's video, not today's. All right. Today we're only going to be working with the first one and the last one. We're not going to be doing the middle one. All right. So let's show you what this looks like. We're going to solve the absolute value of x minus 6 is equal to 3. The first thing I notice is that the absolute value is completely by itself. I'm not talking about like stuff on the inside. I'm talking about stuff on the outside. So here's my absolute value of something, and notice that it's completely by itself. We're going to show you cases where it's not completely by itself, and when it's not completely by itself, you need to get it by itself. But in this case, I got the absolute value of something, and this is a positive number. Since this is a positive number, then I know I'm going to get two solutions. The directions say What we're going to do, I already isolated it. Step 2, we're going to set up my two cases. The first equation is going to be exactly the same. And the second one, I'm going to change all the signs at the very end. So here we go. I'm going to split this up into two different problems. The first problem is going to look like this. It's going to look exactly the same, but we're going to get rid of the absolute values. So it's going to be x minus 6 is equal to 3. The second case, we're going to keep the first part the same. It's still going to say x minus 6. But I'm going to change the signs on the second part. So instead of the 3, I'm going to do the opposite. It's going to be negative 3. So here are my two different equations. The first one, which is exactly the same. The second one, which is almost exactly the same. I just did the opposite of the last part. So we're done with step number 2. Step number 3 says solve both equations separately. So I'm going to solve each one. How do I solve this one for x? Well, all I'm going to do is add 6 to both sides. I get x equals 9. And on this one, I'm going to add 6 to both sides. I get x equals 3. So I ended up with two solutions, which I knew was going to be the case. And when you write your answer, you're going to write it like a set. So we're going to use those squiggly brackets. My first answer is 3. My second answer is 9. Someone asked yesterday too. They're like, does it matter the order? It doesn't, but normally in textbooks and with just people in general, they'll mostly put these in smallest to biggest. So take your smallest number, put it in the front. Take your biggest number, put it at the end. Hey, I don't need to check my answers on this one. I'm only going to need to check my answers when I'm in the middle case. But if you want to see if you did it right, you can always check your answers if you're really not sure. So I'm going to take the 3, plug it back in. 3 minus 6 is negative 3. And when I take the absolute value of negative 3, the answer is 3. That works. I'm going to take 9 and I'm going to plug it in. 9 minus 6 is 3. And when I take the absolute value of 3, it's also 3. That works. So I know I did this right. Okay. All right, that takes care of number 1. Let's take a look at number 2. Same thing with number 2. We're going to go ahead and see, is that absolute value isolated? The answer is yes. I'm taking the absolute value of something. There's nothing around that absolute value on this side of the equation. Okay, so that absolute value is isolated. And the next thing I'm going to notice is this number over here, my answer in this case is positive. So that means I must have two different answers. In order to get my two different answers, I'm going to set up my two different cases. The first case, you're going to keep it exactly the same. So it's still going to say 5 plus 4m is equal to 45. Notice that the absolute values are gone. And then on the other side, I'm going to write 5 plus 4m equals, and I need to do the opposite. So instead of 45, it's going to be negative 45. All right, we're going to solve relatively quickly. Let's see, I'm going to subtract 5 on each side. I get 4m is equal to 40. Divide both sides by 4. I get m equals 10. On the other side, same thing. I'm going to solve for m. So I'm going to subtract 5 on each side. Be careful here. I got 4m equals negative 50. Then I'm going to divide both sides by 4. I get m equals negative 50 over 4. Now that's a great answer, except formative is going to mark that wrong. They don't want decimals. We're going to leave it as a fraction, but that fraction can be simplified by 2. So I'm going to divide the top and the bottom by 2. What I end up with is negative 25 over 2. And that's as simplified as it's going to get. So I'm going to put these in order. My first answer is negative 25 over 2. And my second answer is 10. And again, you can check your answers if you want to make sure that it's right. I'm not going to, in the interest of time. I don't want to make this video super long. Okay, here's where things change a little bit. I want to get the absolute value isolated, and it is not. I have the absolute value of something, and then there's this 7 stuck in the front. Notice that the 7 does not have any operation between the 7 and the absolute value sign. You need to know when there is no operation, we put an imaginary dot, which means that absolute value is being multiplied by 7. And if it's being multiplied by 7, I can get rid of it by dividing by 7. These are going to cancel. I get the absolute value of negative 8r is equal to negative 8. Now the absolute value is isolated. Now I can go ahead and check. Well, let's see. I have the absolute value by itself, and I have a negative number as my answer. And I know if I have the absolute value equaling some kind of negative, this is impossible to do. So I can go ahead and start right now by saying that this is going to have no solution. And I'm done because I know there is no number that exists that's going to give me that answer. We like no solutions as long as we can recognize them. Okay, it makes it a lot easier, a lot quicker. All right, I'm going to ask myself, is this isolated? The answer is no. I have the absolute value of something plus 7. I need to get rid of that plus 7 so I can get the absolute value completely by itself. I'm going to subtract by 7 on each side. I get the absolute value of negative 8n plus 8 is equal to 24. Now that the absolute value is isolated, I have the absolute value of something equals a positive number, then I know I'm going to get two different answers. In order for me to get two different answers, I need two different equations. The first equation is going to stay exactly the same. Negative 8n plus 8 is equal to 24. The only difference is we're going to get rid of the absolute values. On the other side, we're going to take the opposite of what's left over. So this is going to be negative 8n plus 8 is equal to, I need to take the opposite of the right side, so that's going to be negative 24. Now that I have that, we're going to go ahead and solve each one. So I'm going to subtract by 8 on this side. I get negative 8n is equal to 16. Divide both sides by negative 8. N is equal to negative 2 is one of my answers. On the other side, I'm going to subtract 8. I get negative 8n is equal to negative 32. Divide both sides by negative 8. I get n equals positive 4. We put both our answers in order. This is going to be a negative 2 first, then a 4. And we are done with number 5. All right, guys, we got 2 more problems we're going to do today. The other 2 problems are going to be done in a separate video because I don't want to make a super long video for you. First question, is it isolated? The answer is no. I have the absolute value of something, and it looks like it's being multiplied by 8 and added by 4. So let's get rid of that added by 4 first. I can subtract by 4 on each side. I get 8 times the absolute value of 8x minus 2 is equal to 112. This doesn't have any symbol between the 8 and the absolute value, so I need to know there's an imaginary dot, which means that absolute value is being multiplied by 8. And if I want to get rid of the multiplied by 8, I'm going to divide both sides by 8. These are going to cancel. I get the absolute value of 8x minus 2 is equal to, and when I divide these, I actually get the number 14. That 14 is a positive number. The absolute value is isolated and I got a positive answer. That means I must have 2 different answers. If I'm going to get 2 different answers, I need 2 different equations. The first equation is going to stay exactly the same without the absolute value sign. 8x minus 2 is equal to 14. I just realized that in our class, when I split these up, I split this up into 2 different. The first one was highlighted green and the second one was highlighted pink. Sorry, I did that on all of them in class too, and I don't want you to lose your highlighting points. So the first one is highlighted in green, the second one was highlighted in pink. Or else I'm going to look at your notes, and when I grade it, I'm going to say, wait a minute, you didn't highlight, and I don't want that to happen to you. So here we go. The first one highlighted in green. The second one, we're going to keep exactly the same, but I need to switch the second part. So instead of 14, we're going to switch that to a negative 14. All right, now that I have that, let's go ahead and solve. I'm going to add 2 to each side. I get 8x is equal to 16. Divide both sides by 8. X equals 2. In this case, I'm going to go ahead and add 2 to both sides. 8x equals negative 12. Divide both sides by 8. X equals negative 12 over 8. However, on formative, they're not going to like that answer because your fraction can be simplified by 4. And if I divide the top and bottom by 4, I get negative 4. Nope, just kidding. Negative 3 over 2. I'm going to go ahead and write these as a set. Smallest answer first. Bigger answer later. So those are my solutions to that set. Okay, last one, guys. I got 4 minus 4 times 3. Obviously, the absolute value is not isolated. I got the absolute value here, and then it's being multiplied by 4, and then there's this extra 4 here. Let's get rid of that extra 4 first. That's a positive 4. I can get rid of it with a minus 4. These are going to cancel. I get negative 4 times the absolute value of 3x plus 3 is equal to 24. The absolute value is still not isolated. I have that negative 4, and there's no operation between the absolute value and the number. So you need to know that there's an imaginary dot there, which means the absolute value is being multiplied by negative 4. If it's being multiplied by negative 4, I can get rid of it by dividing by negative 4 on both sides. These are going to cancel. Get the absolute value of 3x plus 3 is equal to negative 6. The absolute value is isolated. So now I check my answer, and I see that my answer is negative. And when my answer is negative, that's great because I know that there's going to be no solution. Okay, that is all the notes for today. Tomorrow we will finish up, or on the next video I should say, we're going to finish up the last 4 problems. It should be a quicker video, but the problems are going to be a little bit more complicated. As always, if you have any questions, please feel free to ask.